Hey guys, so for my class project presentation in the wireless security class, I was doing Wi-Fi jamming. So basically in electronic warfare, there's three types of things. I can spoof the thing where I make you think it's something fake is real. So basically fake equals real. I can completely jam it, which means I overpower the signal with noise. And those are basically the two ways you can do it. So I did the jamming because that's easiest. It requires less hardware and it's probably easier for most people. So the setup I used was a small anechoic facility. An anechoic facility is basically an RF quiet environment. I work in the largest anechoic facility in the world, the Benefield Anechoic Facility at Edwards. So I used our small facility, which is about 30 feet by 15 feet. At one end I had the SpecAN, which I can see all the data coming through. In the center of the chamber I had a small laptop. In one corner I had my router, which was wireless, and I had a file server connected off on the outside, which was used to send data so that way I could see how fast the connection was. And then bore-sided off in the other corner was an antenna for my signal generator, and that's a bad looking antenna. So there's that. So given the beam width of my signal generator, I was going to see a lower signal from the signal generator on the SpecAN just because of the antennas I was using. But since the router is pretty much omnidirectional, I would see a different connection. Same with this. So basically, I let the router and the laptop connect, and I started transferring very large files sequentially. So, 20-minute files. And to start, they were at pretty much at 54 megabits, given the overhead of 15%. So I started ramping up the signal generator. And before I get started on that, the frequency domain basically is a single sideband lobe. I was at channel 11. And on a max hold, the signal would look like this when fully connected. Everything outside of channel 11 was pretty much the laptop trying to search, because when it was only the router, it would stay pretty much in channel 11. So to start jamming, I did 80 megahertz bandwidth first, which would cover the entire frequency band from channel 1 to channel 13. And this was an 802.11g router. So it was constrained to channel 11. So I brought it up from negative 50 dBm to 13 dBm, and I could see the signal degrading. The speed would decrease, and at positive 12 dBm, I had a connection. It was very slow. It was only getting bits per second. But once I made the final 1 dBm jump, 1 milliwatt, no, sorry, not 1 milliwatt, the final 1 dBm jump, the connection completely died. And you could see that the strength of the jamming field was actually stronger than the router in the spec in the signal diagram. So I then reduced the bandwidth from 80 to 20 to allow the router to jump channels, maybe to maintain connection, and it actually didn't. So that's pretty easy to jam. 20 megahertz, not too hard. I can do that with a PIC microcontroller. 13 dBm, that's less than 1 watt. I can do that with, again, pretty much anything. I had no amplifiers in the setup. All I had to do was make sure my connections were tight so I didn't have any extra power loss in the cabling. And so to summarize, negative 50 dBm, pretty much no loss in signal. 13 dBm, connection failed. And then, so anywhere in between, I would have varying field strengths. It wasn't quite linear. Sometimes it would be more resilient than others. But the fact that I had to go all the way up to 13 dBm for this really suggests that Wi-Fi is designed for a noisy environment, because at like say 12, you could see the field was stronger, but it still had enough error correction to pull out enough processing gain. And so that's really what I found, is that yes, it's easy to jam, but to do it well, you have to both be close or very well concentrated on either the receiver, on either the computer or the router. Thank you.